from basic building blocks. So I think that's when I realized like I wanted to study engineering, and I didn't want to study subjects where like I had to memorize specific stuff. Yeah.
That's
So
something
yeah,
with engineers, right? We don't really like to buy hard stuff. It's
yeah,
really weird.
exactly.
It's
Yeah.
the same thing sometimes when in engineering, sometimes when you have all this chemistry equations kind of stuff, sometimes you're doing like this combustion chemistry, it kind of feels annoying because that's the products are reactants are there and the products are there and you just have to learn them, and it
Yeah,
kind of felt
exactly.
weird.
Yeah.
But yeah, it's yeah. So like,
Yeah.
when did you decide? Like, I think you did bachelors in aerospace, right? So what
Yeah.
made you decide to choose aerospace? Like, was there some influence, or did you like aerospace or airplanes and rockets, or how did it happen?
Yeah, so I like airplanes even till now. Yeah, it was just something I was fascinated by, like this heavy object like floating in the air.
Mm-hmm.
And growing up, I used to live over the takeoff zone, so it wasn't that close to the airport, but it was underneath the takeoff path for the aircraft. So literally every day, I would hear the planes flying over, and yeah, for some reason, I just liked it. So initially, I wanted to be a pilot. I wanted to be a pilot, and then along the way, I realized, well, I can still be a pilot without it being a full-time career, you know. So, and I realized like I like engineering, so I decided to merge these two fields, and that's how I went into the aerospace engineering program. Yeah, I guess it gave me the best of both worlds.
And so, how did you go from aerospace to additive manufacturing? Was there a specific course, or did you just like found it as a hobby?
No, yeah. So remember earlier I mentioned about how like I tend to be curious about different things. So while studying aerospace engineering, I started hearing about this whole 3D printing technology and the things it could do. And I thought, wow, that's like super interesting, right? But I didn't really pay much attention to it. So it was just one thing I was like, oh, this is very interesting. And then I decided to go do a master's, right? And while I was looking at professors I could work with, I saw this professor in the UAE in Khalifa University. Previously, it was Mazda Institute, and he had an aerospace engineering background, and he was using 3D printing to develop lightweight structures. So it was mainly like composite structures. So I was like, I thought that was really cool because like he was still developing products for the aerospace engineering industry, but he was using this fancy technology which I had seen previously. So I was like, I think I would like to do that. And that's how I made that transition. So it was never for me about the program, like aerospace mechanical. It was always about, or aerospace additive manufacturing. It was always about what's the word? It was always about just exploring these curiosities, and that was like the perfect combination between aerospace and additive.
So yeah, how was your like transition from work to from university for your masters to work? Like, how did you end up finding
Finding,
Immensa? Yeah, like
yeah,
how did you
so
end up finding Immensa, and like how did your work life go about it? Like a brief thing about that, if you can share.
yeah. I mean, it was the same thing. It was still this whole curiosity about additive manufacturing. So I got into the program, obviously, into the master's program, and I was working with AM equipment, and I was doing research it was a wide range of research objectives. So at that point, I was hooked. I really saw the potential for additive manufacturing. And so close to the end of my program, I had told myself I will do the best I can to continue to work in this field. So while searching for jobs, I was searching mainly in this area, like in the AM area. So it was actually, there's always this element of, I don't know, maybe luck, I don't know. But then I was searching, and at the same time, I saw this advertisement for this company that was trying to start something in the area of additive manufacturing. And so for me, it was a no-brainer. Like, I didn't even really research into the company. Like, it was this company doing something in AM, and from the job description, it looked like something that I would really be interested in, because there was a lot of R&D that was intended to be done. So I applied, interviewed, and that's how I started working in the UAE.
One more question is, everyone has it, I think. After your master's, why did you decide to work instead of continuing to study, or did you want to take a break and then work? Like, what was the reason of choosing work over further studies or PhD at that point of time?
Yeah, at that point. Well, I would say, if I think about it, the main reason was I probably felt at that point if I went on to do a PhD, I probably wouldn't have done a PhD in AM, right? But then I had this job offer, which was giving me an opportunity to work in the AM industry. So that was one of the reasons. The second reason was I also wanted to gain some work experience, like after my bachelor's, I did some work with the Ghana Civil Aviation Authority for like a year, but that wasn't really like an engineering kind of job. It was, although it had some engineering components, it was still very kind of like policy, like, so it was mainly about safety, like ensuring that the aircrafts which are flying are operating in a safe manner. So it was a lot about regulations and ensuring that the engineers on the ground are doing the right thing. But then I wasn't doing the engineering. So I think it is just that yearning to actually have some engineering experience, to be able to understand the problems of clients, actual problems, and be able to find solutions to these problems. So I would say that was the second reason why I decided to go for the job than to go straight to do a PhD.
And so during your work, like the years of work that you've worked in the UAE,
yeah,
what was your biggest challenge, or what was your biggest experience that made you change or evolve into a new person? Or was there such an experience, first of all?
Yeah. I mean, like, I remember when I joined, the very first project we had was to design a drone for a client, right? And up until that point, I had designed a few stuff, but I hadn't really designed something that had to work, within a specific, very tight time frame, and it's like, you can't really, there's not much room for error, like the competition for this person was on this date. So we had a very narrow, I think it was about like 2 week time frame to conceptualize on paper, design using the CAD software, print the stuff, test it, print new models, test it, and it should work. And that was like the first assignment that we had. So for me, I think that quickly made me realize, or that quickly helped me grow in terms of, even though the deadlines might be tight and maybe the task might seem quite huge, it can be done. Like, it wasn't something impossible. It's not like no one has designed a drone before, right? it just helped me develop this thinking that there are several things that you can do so far as like you believe you can do it. Let me just put it this way. Yeah, and you just need to work at it and get it done. So I think that was helpful. And and then we also had several projects that helped me learn a lot about different industries. Because as you would know, additive manufacturing cuts across or is useful in several different industries. And so it's like almost every week I'm learning something new about some new industry. Like I was actually surprised when we actually had to do something for the chemical industry. I never really thought like just focusing on additive manufacturing would take me to the chemical industry. I mean, we did stuff for construction, we did stuff for civil engineering. I mean, it's the same as construction, for automotive, for aerospace, for medical, like literally almost every industry you can think of. I had to learn something new about that industry and develop applications, that would help the industry. So I think that helped me grow a lot. Yeah.
I remember when I was also working, there used to be people with really weird requests, and you'd be like, what? Like, is this? Because the thing with additive manufacturing is you have an application, but you have materials, you have the technology, and you have very limited amount of materials. So sometimes they cannot match the mechanical requirements or the thermal or the chemical requirements. So you'll be like, these are all the materials I have. So I need to check if your environment, my material can work in your environment or not. That's that was like the challenging part, and I think that's where the aim is headed. Like at least developing more materials.
Yeah.
So how was your transition from work to PhD? Like, how did you go about it? The most important thing is, how did you select a supervisor? I'm not going to ask university because I think that's irrelevant, but how did you choose your supervisor? Topic is something that everyone can have, but how did you go about, you saw this supervisor and you're like, I want to work with him. What made you choose that?
Well, so it still goes back to this whole idea of me being curious about AM and just doing things that would allow me to explore these curiosities. So with the advisor I'm currently working with, so I did my research online, and I realized he was really doing a lot of stuff in the metal AM field. And I already knew that I wanted to get into metal. So previously I was working mainly in plastic 3D printing, but I knew I wanted to get into metal, and he was already into metal, and he focuses only on metal 3D printing. So that was one marker that like, oh, okay, at least this guy, he has the expertise in like mainly metal. The second thing is he was more of a materials guy. And from my experience in the 3D printing industry, I realized one of the biggest challenges was the material, right? Because before, or even presently, there are just very few materials that you can successfully 3D print with, right? And like in the field, we understand the possibilities that can open up if you can print in much more novel materials, or materials which have better properties. Yeah, so that was the second thing, because he was a hardcore materials guy and he knew things I didn't know, and I knew that there was so much I could learn from him when it comes to microstructure and like what is really happening deep down in the material, like why the processing might make the material behave differently. Like even though the same material, you use different processing parameters, but you get different properties. There are like specific reasons why that happens, and it's all like deep down in the microstructure. So I knew, okay, this is a guy I could learn a lot from. And the third is I also noticed that he wasn't working solely in academia. Like, in academia, there's this tendency for researchers to be in their own silo, and they are not interacting with the rest of the world. So they are solving problems, but the problems are not problems that the world needs to be solved. I don't know if that makes sense.
Yeah.
Like those problems are important, like they are probably fundamental issues, but they're now more interested in, applied research. So the research, I was looking for professors whose research can be easily translated into like commercial industry to make processes more efficient and productive. So yeah, so I think these were the three things I was looking for, and I saw all these three things in my current advisor. Yeah, so that was the guiding principle.
Okay. Like, how did you feel? Because I know you did not have lots of background in materials similar to me. Because
Yeah.
I remember when I went and sat in my materials class, I didn't understand anything. I was like, everything was going over my head. I just
Yeah.
looked around and I was like, I asked the guys, like, do you understand anything? They were like, no. And like, after a while, the more classes you attend, you'd be like, okay, so because I did mechanical, so
Yeah.
you might be knowing about it. So you realize from the mechanical properties, you look at a larger scale, and when you do
Yeah.
materials, you look at microstructure scale. So you're like, okay,
Yeah.
this is what's happening in the microstructure that's affecting the mechanical.
Yeah.
You like you're connecting the dots, and it's a really
Yeah.
amazing feeling. I don't know, I don't know how to describe it.
Yeah.
Like,
Yeah.
did you feel like that? You're like, oh, okay, this is why that was happening.
Yeah. Like, yeah. So that was actually one of the reasons why I felt, okay, I need to really understand how this works. Because in some ways, it feels a lot like magic, like, for lack of a better word. Because it's like there are these things, like basically just controlling, let's say, during heat treatments, like just the rate at which you heat the part and the rate at which you cool it can completely change the microstructure. And
The
so,
properties in the end.
yeah, exactly. And so it's almost like magic, like, because if you do not really understand the nitty-gritties, you'll be like, oh wait, how did this happen? Even the last time I was watching something about it. I don't know if you've heard of Damascus steel, but it's basically a steel that has a very intricate pattern on top of it.
You keep folding back and forth again the
Yeah,
Damascus.
so currently people are using that technique to recreate that pattern. But originally, that pattern was created not by combining different metals. It was made from one ore, like one rock, which was melted and cooled, and they did the processing and everything, and they get that pattern. So it's like there are these questions. Okay, so why does this pattern develop when you use this particular rock? And from the video I was watching, that was because there was this particular element. I think it was vanadium, and it was present in like 0.01% quantity. So just that 0.01% of this element, is changing everything.
Usually the vanadium and all the microalloys, it prevents your grain from growing. So it does the Zener effect or the grain boundary pinning. So it doesn't allow sometimes the grain boundary to grow. So I think maybe that kind of helps in a way. And also there was, I don't know about this video, maybe you can share later, but I saw a paper where they were trying to 3D print Damascus steel. I was like, this is gonna be next level. Because it's one of the really oldest like alloys or steels which were used, Damascus steel.
Yeah, exactly. So so I think that's the thing about materials and how it relates to the mechanical properties that makes it so fascinating. And if we are working in the 3D printing industry, then it's super important, right? Because they are literally, I think even now some people are doing what they are calling in situ alloying. So it's the idea of whilst printing, you're creating the alloy in the 3D printing machine, like during the process. And that requires like a deep understanding of the material and how it evolves, like during the process.